about the different modulation technique which is used in the digital communication system. Before seeing actual part, the sampling, quantization and encoding, these are the three important steps about the pulse code modulation technique. But here today we will going to discuss about what is the pulse amplitude modulation. In pulse amplitude modulation, the amplitude of the carrier consisting of the periodic train of the rectangular pulses is the varied in proportion sample value of the masses signal. See, in case of the pulse amplitude modulation, basically there is a first step for the ADC, that is the analog to digital conversion, and it is the foundation of the PCM. The palm, for this example we clearly understand to you, here is the analog signal, and that analog signal is able to convert it into the pulse amplitude modulated signals. Then it is able to convert it into the train of the pulses. So whatever the information bearing signal, that information bearing signal is converted into the train of the pulses, and positive as well as on the negative side, and which is very important steps about the pulse code modulation technique. The pulse amplitude modulation is the first step in the ADC, and it is the foundation of the PCM. Then PAM takes the analog signal, it will be takes the analog signal and it is sampled it. And what is the sampling rate? The sampling rate is the sampling frequency which is equal to twice that of the modulating frequency. Then here it will be generate the series of pulses based upon the results of the sampling, and the term sampling means measuring the amplitude of the signal at equal interval. This is the very important steps. Then in pulse amplitude modulation, here is the pulse amplitude modulation, here is the sinusoidal modulating signal. In case of the sinusoidal modulating signal, here is the information bearing signal, or you called it is the masses signal, and that masses signal is a sampling. Once it will be sampled, the train of the regular pulses which is modulating with, or it will be amplitude of this sampling signal is a varying accordance with the information bearing signal, and which is called as the pulse amplitude modulated signal. It is not a flat top sampling, natural sampling. It will be naturally, it will be able to increases or decreases the amplitude level according to the information bearing signal, which is called as the palm signal. Then after that, the time division multiplexing. In case of the pulse code modulation or any digital communication system, the time division multiplexing is an important feature of pulse amplitude modulation. Basically the pulse amplitude modulation technique, pulse width modulation technique, pulse position modulation technique, these all are the analog modulation technique, but it is very important because of that after converting the train of the pulses, before we have to be process that all that things on the analog signal. Then and important feature of the palm is the conversion of the time, that is the given masses signal transmission of the associated, the palm engages the communication channel for only the fraction of the sampling interval on the periodic basis. Hence sum of the time interval between the adjacent pulses of the palm wave is cleared for use by other independent masses signal on a time shared basis. So joint into utilization of the common channel by the independent masses signal without the mutual interference, which is called as the time division multiplexing. Then after that, a time division multiplexing, this is the basic block diagram of the time division multiplexing. See, here is the pre-alias filter, this is the low pass filter, and the input messages, you have able to apply the message on the low pass filter. Here is the n number of the message signal is able to pass through it. Therefore message input 1, 2, 3, 4 up to the n number, it will be able to apply on the low pass filter. Then after applying the input message to the low pass filter, it will be all the messages will be going to the commutator, and here is the commutator, it will be able to select one by one the message signal from the low pass filter 1, 2, 3, 4 up to the n number of the low pass filter, and which is able to apply to the pulse amplitude modulator. Then commutator and the decommutator both are synchronized. Then the pulse amplitude modulator, the amplitude of the pulses will be changes with reference to the information bearing signal, just like this. Here means the amplitude of the each pulses will be varied in accordance with the information bearing signal. Then which is called as the timing pulses, and that timing pulses, so the output is given to the communication channel. Then after given the information to the communication channel, then it will become to the pulse amplitude demodulator. Means you have to be separate the pulses, whatever the pulses will be given, which is a predefined level. Then the decommutator will be, again it will be able to convert into the original form by using the reconstruction filter, and your original message should be obtained. Once the first message is able to apply, that all the process should be completed, then it will be take for the second, then it will be take for the third. In this way, the priority basis level, all the information should be received and it will be out from the decommutator. And this is the basic operation of the time division multiplexing system. Then in case of the time division multiplexing system, here what happens basically, there are the input messages, that there is the input message x1t, x2t, x3t up to the xm of t, which is able to apply from the low pass filters. In the previously we seen in the with the help of the block diagram, here actually the process is happening. The first data, here is the first data, and that first data will be come to the here, apply on the channel, decommutator will be separate out, applied on the low pass filter into getting the output, that is the x1t. Similarly for x2t, x3t, xm of t. In this way, at a time one by one, it will be receive the data parallelly and move towards the transmission channel. Then after that, the multiplexed palm wave, here is the time duration for the first pulse to the next pulse. There is a x1, x2, x3, x4 up to the x of m. There is the first frame, second frame, third frame. In this way, there are the m number of the frames is able to apply to it. Then for this waveform illustrated the time division multiplexing for the two masses signals. Here are the first masses signal and here is the second masses signal, and both are synchronized together here. Then here the pulse amplitude modulated, pulse width modulated and pulse position modulation, that all are the analog modulation technique. Here is the information bearing signal. In case of the information bearing signal, the amplitude of the each pulses should be varying with respect to the analog signal. Then amplitude modulated pulses, then pulse width modulated pulses, means once your amplitude should be varying, the width of the each pulses should be varying according to that. And the position of the modulated pulses means either it will be increases or decreases, the position of the each pulses should be changes with respect to the information bearing signal. Then in the pulse position modulation, in this type the sample waveform has the fixed amplitude. Here is the fixed amplitude and the width, whereas the position of the each pulses is varies as per the instantaneous value of the analog signal. And the pulse position modulation signal is the further modification of the PWM signal, and it has the positive thin pulses corresponding to the starting edge of the PWM pulses and the negative thin pulses corresponding to the ending edge of the pulses. Means starting from here, from suppose this is the first pulse in case of the pulse width modulation. In the starting edge, the positive pulse, once the amplitude should be increases, and here up to the here amplitude is a constant, and after that this edge is completed, the amplitude should be decreases towards the 0, then the negative pulse should be generated. For the next pulse here, starting from here, the amplitude is increases, then your positive pulse is generated. Once the amplitude should be decreases for this pulse, then the negative pulse, means every time it's the position of that pulse it should be going to be changed. I hope that all of you understand this pulse amplitude modulation, pulse position modulation and pulse width modulation in the analog modulation technique. If any doubts, please you write on my comment page. Please subscribe my channel and please click on the bell icon. Thank you.